In section 4.3, we're going to review some terminology about the circular functions. So even though trigonometry is the study of three-sided figures, we want to be able to understand angles of rotation in a circle. So it might not be completely apparent why we would call something on a circle trigonometry, but if we take a little bit closer look at it, we can kind of see why. So on my paper, I drew a basic XY axis. And to kind of review, we have four quadrants that splits up into quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So imagine that I just go and choose some point in quadrant 1, this coordinate here, xy. And if I connect from the center of the circle to the edge of the circle, then that is a length of r for the radius of the circle. Now imagine that I just kind of drop down a line here, and I call the angle from the x-axis to the radius that I've drawn here, theta. Well, using the fact that this coordinate is xy, then we know that this horizontal distance here is equal to x, and we know that the vertical distance is equal to y, because that's the location of my point here, xy. And so lo and behold, inside our circle is a right triangle. And so that's how we can use trigonometry in a circle, using the same SOHCAHTOA relationships that we reviewed before. So what we're going to do is define the trig functions for any angle theta in the circle, and then look for some patterns in the circle just to kind of help us find the trig functions a little bit more quickly. So if you want to move this coordinate xy around the circle and kind of see what happens to the triangles when you do that, there's a great online demo, and I've typed out the demo for you here in Desmos. If you go online and look at this Desmos app, you can actually move this point around and watch all the right triangles that it forms as it goes around the edge of the circle. So I encourage you to do that because it's kind of cool to watch. But let's imagine that we're using this point here, and we can define our 6 trig functions then using SOHCAHTOA and this point P that we chose above. So r is the distance from the origin to the point, and so using the Pythagorean theorem, r is also equal to the square root of x squared plus y squared. So we said before that sine is equal to the ratio of the opposite side to the hypotenuse. So if we go to our diagram here, here's theta. Opposite of theta is y, and the hypotenuse is r. So that's how we get the ratio y over r. And we said cosine was equal to the ratio of the adjacent to the hypotenuse. So again, here's theta. Adjacent or next to it is side x, and the hypotenuse is r. And so there's our relationship x over r. Tangent is opposite over adjacent. And so opposite is y over adjacent x, and this holds true as long as x is not equal to 0. And what this tells us is there's going to be a couple places on the circle where tangent does not exist. So here's the other 3, cosecant, secant, and cotangent are reciprocal functions, and you can see that they have the reciprocal measures of sine, cosine, and tangent, but they all have a location where they might not exist. The reason x and y can be 0 is because we have these 4 kind of points on the axes called quadrantal angles where that can occur. The radius can never be 0, so sine and cosine are all set. So we'll explore what that looks like later on when those things don't exist. But there are some great patterns here to kind of understand when sine and cosine might be positive or negative. On a regular right triangle in space, we can't have negative sines and cosines, but on the circle, it may happen that we have negative values for sine, cosine, and tangent. So we're going to talk about reference triangles in the next video, but there's a little acronym that can help you understand when and where our trig functions are positive and negative. So if you can remember that all students take calculus, this is going to help you understand where and when our trig functions are positive. So quadrant 1 is all, quadrant 2 is students, quadrant 3 is take, and quadrant 4 is calculus. In quadrant 1, both the x-axis and the y-axis give values that are positive. And so if you look at our trig definitions, that means that sine, cosine, and tangent are all positive. But in quadrant 2, here we are on the x-axis where it's negative, but the y-axis is still positive. And so if you look at our definitions here, sine has a y in it, so that's positive. Cosine has an x in it, but that's negative, and tangent has an x in it, and it's negative. So students stands for sine, so sine is positive in quadrant 2. In quadrant 3, both the x values and the y values are negative. So if we look at our definitions here, sine will be negative, cosine will be negative, but the ratio of two negative numbers is positive, so t stands for tangent. In quadrant 3, tangent will be positive. And in quadrant 4, we're back to a positive x values, but negative y values. So if we go to our definitions, then sine will be negative, cosine will be positive, and tangent will be the ratio of negative to positive, so it will also be negative. So calculus stands for cosine, so in quadrant 4, cosine is positive. This is true for both the trig functions and their reciprocals, so cosine and secant, tangent and cotangent, sine and cosecant, and all the functions. All students take calculus.